Okay, welcome to section 14.4, page 1 on the normal distribution. And before I forget, I want to tell you something about the classwork from section 14.4. On the back side, you do not have to do part B here, so just go ahead and cross that off. Okay, next, I would like you to get out your textbook, and if you don't have one, you'll be able to read it here, and read about ergonomics. And this is page 759. Go ahead and read just this paragraph, pause the video, and then turn it back on. All right, so you can see that if we know that something is a normal distribution, if we know that things are normally distributed, it's going to give us some information and help us to know, to answer questions about how people can fit comfortably into their environments. So what is the normal distribution? Well, you hear people talk about it as being a bell-shaped curve. So you notice here it looks like a bell. So also notice it doesn't have to fit perfectly, okay, but it's an approximate curve like that. So what are the important characteristics of it? 1, it's bell-shaped. 2, it's symmetric with respect to its mean. Its mean is right here in the middle. So if you folded it on that line, you'll see that they're mirror images of each other. What's on this side is on that side and vice versa, okay? The mean, median, and mode are the same value. So this number right here, so this corresponds to some number here. It is the mean, median, and the mode. So it's the most frequently occurring number, that's the mode. It's right smack dab in the middle, that's the median. And with the mean, it's if you add up all the values and divide by the total number, it's also that value. So that makes it special. The total area under the curve, everything we consider to be under the curve, 100%, or if we're looking at decimals, 1. Now, the most important part, and the part we're going to be using here, is how much is within 1, 2, and 3 standard deviations from the mean. We'll be able to say a certain percentage is within this. So right now this doesn't make sense, but I'm going to explain it to you with these pictures. So what we're going to do is we're going to say we know that the mean is right here in the middle, okay, from the information we got above. Then notice it says 68% of the data values are within 1 standard deviation from the mean. When they say within 1, that means we can go up 1 and we can go down 1 from the mean, and that will include 68% of the data. Okay, so before I can draw this, I have to continue reading all these. Notice it says is that basically all, 99.7, or all of the data is within 3 standard deviations from the mean. So that means you go up 3 and down 3 and you get basically everything. So the way we're going to always do these is we're going to say on this side to about the end of the curve is going to be 3. We're going to divide it into 3 equal pieces. Okay, it doesn't have to be perfect, just approximate. And that will help us to know what the standard deviations are. So right here we have 1s because we went up 1. That a little bit larger. And here we went down 1, so minus 1s. So let's take our ruler and show what we've got here. So we'll draw a line there and draw a line here. And what we're going to be able to say is the data that's contained in this area that I'm shading is 68%. When you look at the picture, does it look about 68%? It should look like it's more than half to you. Hopefully it does. Okay? So that's what it means. Go up 1 standard deviation, down 1 standard deviation, and the area in between is 68% of the data. So we're going to do the same thing to show 95 within 2. So again, divvy it up into 3 equal pieces. So 1, 2, 3. Then 1, 2. Oops, I didn't go quite far enough there. Let me fix that. It's a little bit off. 3. Okay, so here we're going to say this is 1 standard deviation, this is 2 standard deviations, 3 standard deviations. So minus 2 standard deviations, minus 3 standard deviations. Okay, and that 1 is kind of hard to put in there. It's too close. Okay, but we're interested in going 2 standard deviations. Okay, so we're going to shade here. What's within 2 standard deviations, going up 2 and down 2 from the mean? Well, that's going to be 95% of the data. Okay, when we look at this picture, does it look like what we have shaded there is 95%? Hopefully it does. So let's make this even more clear. Let's say this is within 2 standard deviations of the mean. And let's label this one as within 1 standard deviation of the mean. And now we've got one last one here to do. We need to go all the way to 3. So 1, 2, 3, 1, 2, 3. Here's the mean. So 1 standard deviation, 2, 3, and then -1, -2, -3. So you can see that the curves go a little bit further, but it's kind of hard to show here. We're going all the way. So this is the part we're shading now. So basically we've got everything is what it's saying. 99.7%, which is basically all of it. So this here includes 99.7%. So there could be a little bit of data beyond the 3 standard deviations, but you've got most of it here. So within 3 standard deviations of the mean. Okay, so let's go ahead and use this now. Okay, so for this example number 1, it says assume the distribution has a mean of 10 and a standard deviation of 4. Assume it's a normal distribution. You need to add that. Use this 68, 95, 99.7 rule, which is what we had listed there, to find the percent of the values in the distribution that we described between 6 and 14. Okay, so before we start talking about between 6 and 14, we've got to get it marked off right. So we're told that we have a normal distribution, which is why we drew this shape. We're told that the mean is 10. We know the mean is right in the middle, so let's put 10 in there, okay? Then we are going to count in terms of standard deviations. So in our case, standard deviation is 4. So we're going to go ahead and put in our 3 equally. We know that most of the data should be included in 3. So 1, 2, 3. Okay, so these represent our standard deviations. Now, how much is a standard deviation? Well, in this case, it's 4. So we were here at 10. We want to add 4 to that. What do we get? 14. We want to add another 4. What do we get? 18. Add another 4. What do we get? 22. Now we're going to subtract. We're going to go down. So 10 minus 4, always do it in terms of standard deviations, would be 6. 6 minus 4 would be 2. And 2 minus 4 would be -2. And you can do all that on your calculator if you want. Okay, so now we've got it labeled. So basically what we're seeing here is whatever this data is, basically all of the data will be values between -2 and 22. Okay? Now, they're asking us between 6 and 14. So we're going to go ahead and draw our ruler and mark off 6 to 14. There's 6, there's 14, and we're trying to figure out what percent of the data is in here, in between 6 and 14. Well, isn't this within 1 standard deviation? This is 1 standard deviation, and this is 1 standard deviation, right? This is within 1 standard deviation. So the rule says 68% of the data is within 1 standard deviation. Okay, this is 68%. So we would answer 68% of the data is between 6 and 14. Since these values are 1 standard deviation from the mean. Okay, so that's our answer there. Okay, so we'll go on to the next problem. We're going to start the same way. We're going to start with the mean is 10. So we put the mean right in the middle, and then the standard deviation is 4. So we're going to count over, we know always 3, 1, 2, 3, and 1, 2, 3. Okay, so we're standard deviation is 4, so you're adding 14, 18, 22. You just keep adding 4 here, you're subtracting 4. Okay, so those are our values, same as over here. Now this time we're interested between 10 and 14. So we've already got a line drawn at 10, we need to draw the line at 14. Let's go ahead and do that. And then we're going to shade in between, that's what we're interested in. Okay, well this time we only went up 1 standard deviation. We didn't do the down part. So we know that this whole thing is 68% if we tack on this piece. But we have how much of it? We only have half of it. Remember, this line right here is right in the middle. These two halves, they're halves. They're exactly the same. If you fold along the line, that is the same as that. So if those two are the same, then what can we say about this? Isn't it just half of 68? It would be 68% divided by 2, or 34%. Okay? So we would say 34% of the data is between 10 and 14. Okay, and that's the answer there. And I believe you have some classwork to do. So, well, no, we're going to do another problem. So just go ahead and go on to page 2.